Hello student, welcome to Ideal Science Karta YouTube channel, Rotational Dynamics lecture series, and this is the part 9. If you didn't see the last videos, please see it. In those videos we have covered so many important points. Today we are going to start new points, that is moment of inertia. Moment of inertia, see the definition. The sum of product of mass of each particle and square of its distance from axis of rotation is called as moment of inertia, and it is denoted by I. So moment of inertia is the product of mass of each particle and square of distance from axis of rotation. So the formula is moment of inertia is equal to mass into distance square. From the definition, this formula is arises. Moment of inertia is equal to mass into distance square. Mass is represented as m, distance square means r square, and moment of inertia's for symbol is I. So I is equal to mr square. This is equation number first, and this is the basic equation of moment of inertia. SI unit is kg meter square because mass unit is kg and distance square means meter square. So SI unit is kg into meter square and CGS unit is gram into centimeter square. So this is the basic information of moment of inertia, definition, formula, and SI and CGS unit. So these are the basic information of moment of inertia. See the next. Now we are going to start expression for moment of inertia. If the body consists of number of particles having masses m1, m2 up to m of n, situated at distances of r1, r2 up to r of n from the axis of rotation respectively. So see in figure, this is the first particle of mass m1 and this is at a distance of r1 from axis of rotation. This is the second particle m2 having mass m2 situated at a distance r2 from axis of rotation. This is the next and last particle having mass m of n and distance r of n from axis of rotation, and all particles are rotating about this axis of rotation with constant angular velocity omega. Therefore moment of inertia of body is given by. So we are going to find where we have to find moment of inertia of this body. So I is the moment of inertia of body, and I equals to I1 plus I2 plus up to I of n. What is meant by I1? I1 means moment of inertia of first particle. What is meant by I2? Moment of inertia of second particle. And what is meant by I of n? Moment of inertia of nth particle. So I1's formula is m1r1 square, I2's formula is m2r2 square, and I of n's formula is m1rn square. So put in this equation, so equation will become I equals to m1r1 square plus m2r2 square plus up to m of n r of n square, and this equation can be converted in the form of summation. So I equals to summation of m(i)(ri) square, where I started from 1 because starting is from first particle and end up to n because last point is n. So I is equal to summation of mi(ri) square. This is equation number 2, where I started from 1 end up to n. This is the equation of moment of inertia of the body, and this is equation can use for ordinary body only. If the body is rigid, then moment of inertia is given by, and what is meant by rigid body? The distance between two particles remain constant after applying force is called as rigid body. फोर्स अप्लाय केल्यानंतर दोन पार्टिकल मधलं डिस्टन्स जर का चेंज होत नसेल, then it is called as rigid body. So moment of inertia of rigid body is given by I equals to integration of r square into dm, where r is the average distance of all particles and dm is the small mass of small element of rigid body, just like we use here m1, m2, m of n. Like that, dm is the mass of small element of rigid body. So these are two equations. Equation 2 is used for ordinary body. This equation is the ordinary equations of moment of inertia, and equation 3 is used for only rigid body. Radius of gyration. Definition: the perpendicular distance between axis of rotation and center of mass of body in order to study motion of body is called as radius of gyration of body, and it is denoted by k. So radius of gyration means it is a perpendicular distance and in between axis of rotation and center of mass of body. Axis of rotation आणि center of mass of body यांच्यामधलं distance means radius of gyration, and it is denoted by k. Radius of gyration is given by k equals to under root of I upon m. This is the equation of radius of gyration, where I means moment of inertia, m means mass of body, and k means radius of gyration. SI unit of radius of gyration is meter and CGS unit is centimeter, because it is a distance, perpendicular distance between axis of rotation and center of mass of body. So see the next. Now we are going to study about physical significance of radius of gyration. We know that the equation of radius of gyration is k is equal to under root I upon m. In this equation, m means mass of body, I means moment of inertia, and k means radius of gyration. From above equation, it is clear that if the value of k is maximum, then mass is farther longest from the axis of rotation. In the point first, it is clear that if the value of k is maximum, then mass is located farther from the axis. ॲक्सिस पासून मासची पोझिशन ही लॉंगेस्ट असेल, फार्दर असेल. इफ द व्हॅल्यू ऑफ के इज मिनिमम, then mass is closely distributed from axis of rotation. If the value of k is minimum, then mass is near to axis of rotation, closely distributed to axis of rotation. From point 1 and point 2, it is clear that the term of radius of gyration is used to represent distribution of mass from axis of rotation. If the value of k is maximum, then mass is at long distance, and if the value of k is minimum, then mass is situated near to the axis of rotation. So remember these 2 points. Moment of inertia is analogous quantity of mass. This is the new point. Now see here, in linear motion is caused due to the force. Force is equal to mass into acceleration. That is, F is equal to m into a. F is represent force, m is represent to mass, and a is represent to acceleration. So in rotational motion, torque is equal to moment of inertia into angular acceleration. That is, torque T equals to I into alpha. T is represented to torque, I is represented to moment of inertia, and alpha is represented to angular acceleration. So see here, force F in linear motion is analogous with torque T in rotational motion. Force F is analogous with torque T. Force F is in linear motion, so torque T in rotational motion, and they are analogous with each other. Linear acceleration A is analogous with angular acceleration alpha in rotational motion. So see that this is a linear acceleration A, and this linear acceleration A is analogous with angular acceleration alpha in rotational motion. So what is remain? Mass is remain in linear motion, and moment of inertia remain in rotational motion. Therefore, mass in linear motion is analogous with moment of inertia in rotational motion. So this mass of linear motion is analogous with moment of inertia in rotational motion. So see here, linear motion is occurs due to the force, while rotational motion is occurs due to the torque. So force is analogous with torque. So in linear motion, linear acceleration is occur, that is A, and in rotational motion, angular acceleration is occur, that is alpha. So F is analogous with torque T, linear acceleration is analogous with angular acceleration alpha. So mass is analogous with moment of inertia. Mass is represent inertia of linear motion, while moment of inertia represent inertia of rotational motion called as rotational inertia. So mass is used in linear motion called as inertia of linear motion, and moment of inertia is used in rotational motion called as rotational inertia. This is the physical significance of moment of inertia. So thank you for watching video. If you like our video, please subscribe our YouTube channel, and thanks for watching video.